Have you heard about Hooke's law before? I know maybe you have not heard about it. In this video, we are going to analyze Hooke's law and we are going to explain it in detail so that you can actually use Hooke's law in solving problems in elasticity. Welcome to Physics Me. Without taking much time, let's look at Hooke's law together. Now, in the last video, we say that we have a law that looks at the relationship between what? Between force, applied force on an elastic material, and the word extension produced. There is a relationship between the applied force and the word extension produced. And the law that governs that is the law we call what? Hooke's law. So what's the law all about? So Hooke's law states that if the elastic limit is not exceeded, then the extension E produced in an elastic material is directly proportional to the applied force or load F. Okay? Hooke's law states that if the elastic limit is not exceeded, or provided the elastic limit is not exceeded, then the extension E produced in an elastic material is directly proportional to the applied force or load F. You know, in some questions we may use load. Load is still a force. So applied force or load F. Okay. Now we are still going to explain what this law is all about, because we can see extension being directly proportional to what? To force. Now, one important term that was mentioned here is elastic limit. We are going to explain elastic limit when we look at the graph between force and what? Extension. And from that graph, there are other points we are going to explain, like the proportional limit, the proportionality limit. We talk about the yield point, the ultimate load, and the rest of them. So we are going to look at these points when we start looking at the what? The force extension curve. We'll use that to explain elastic limit. Now let's look at the law itself. The extension produced in an elastic material is directly proportional to the word applied force if there is a condition. If the elastic limit is not exceeded, that means if we exceed elastic limit, that this particular law will no longer do what? Will no longer be in existence for that particular elastic material. So once the elastic limit is exceeded, then that material will no longer obey what? Obey Hooke's law. Yeah, once you exceed elastic limit. And that's why in the law it started with if the elastic limit is not exceeded. If the elastic limit is not exceeded, provided the elastic limit is not exceeded, this law will hold for any elastic material. So let's look at the mathematical implication here. From the mathematical implication, we'll now begin to see what it means by extension being directly proportional to what? To force. We'll see what it means. Does it mean that when force increases, extension increases, or does it mean that when force increases, extension decreases? We are going to see it, and practically also. So we know that in direct proportion, when you did variation in mathematics, you talked about direct variation, inverse variation, and so on. So in direct proportion, we can now write this as F is directly proportional to what? E, where F is force and E is what? Extension. Now we know in mathematics, when we have an expression containing the variation sign or the proportionality sign, we always remove it, and when you remove it, you replace it with a equality sign and introduce a constant. And we know that we normally use the letter K for constant. So if I do that, F will now be equal to K what? E, where K is a constant of proportionality or proportionality constant as the force constant. Force constant or elastic constant. So K is the force constant or the elastic constant. The force constant or the elastic constant. Let me call this equation equation 1. Equation 1 because we'll be generating series of equations in Hooke's law. From Hooke's law, we'll be generating series of equations. Okay, so F is equal to KE. We have said that K is the force constant or elastic constant. We are coming to that. Okay, so if we make K the subject of formula here, from equation 1, we really want to define K and also state the implication of K immediately. So from equation 1, we have that F is equal to KE. Therefore, if I make K the subject of formula, K will be equal to F over what? E. So F is the force, E is the what? Is the extension. So you notice that K is force per unit extension, right? So what is the force constant? The force constant is the force required to produce a unit extension in a material. So the force constant K is the force required to produce a unit extension in an elastic material or substance, in an elastic substance. So the force that will produce 1 meter extension in an elastic constant. So it means that if I have an elastic material, like this material is elastic. Let's say that the length of this material is 5 meters, right? The force required to move this material from 5 meters just to add extra 1 meter. The force that will add additional 1 meter on an elastic material is what we call what? The force constant, or the elastic the elastic constant. So we say the force constant is the force required to produce what? A unit extension in any given elastic material. In any given elastic material. That's the force constant. So the force required to produce 1 meter extension, a unit extension, to extend a body by 1 meter. The force you need is what we call the force constant. So if this is 5 meters, the force required to move it from 5 meters to what? To 6 meters is force constant, because the extension is just what? 1 meter. I hope that is clear. Okay. Now, we have other things to say. Now, force constant, it is constant, meaning it cannot change for any given material. It means the force constant for a metal like iron is constant for iron. Once it is iron, they will have the same force constant. So if you pick iron, this iron, and you pick another iron, and you pick another iron, they are all the same iron, and they are separate iron like this, but the same material of what? Iron. The force constant here, the force constant here, the force constant here will be what? Will be the same, because that's why it is called a constant for any given material. But it will not be the same for maybe if you have copper, right? And you have copper again, and you have copper. This is copper. Let's say this is copper, and copper. Now, the force constant for this copper will also be what? The same. But they will be different from that of what? Iron, because iron is a different material. But as long as all these are copper metals, then their force constant will be what? Will be the same. For iron, the force constant here, and here will be what? The same. For copper, this force constant the same. But the force constant of copper is different from that of what? Iron, because they are not of the same substance. But when you have materials of the same substance, definitely they will have the same force constant or elastic constant. Alright. The force constant depends on the on the material. So we call it the stiffness of a material. So the force constant depends on the nature of the material. Thus, it is the stiffness of the degree of extension in an elastic substance. So the force constant K is dependent on the nature of the material, nature of the substance. Depends on the nature of the material. So it is the stiffness, how stiff, you know what we mean by being stiff, how tough, how stiff the material is. So it determines the degree of extension, or the extent to which a body can be what? Extended, or to which a body will undergo extension. So there is a material that you will have. You see, a little force now is extending this. But there is a material that if I want to extend it, I will need a larger force. That means that material is stiff. The stiffness of that material is greater than this particular one. So, because this one and that material are not of the same what? They are not of the same nature. So, what determines the extent, the degree of extension in a body, in any elastic body or elastic substance, is the what? Is the force constant. Is the force constant. Now, before we end the class, what exactly is this law talking about? Having established what the force constant means, what is this law talking about? Now, if we say that force is directly proportional to extension, the implication is that for every increase in force, there will be an increase in the word extension. There will be an increase in the word extension. So as force increases, extension will do what? Increase. That's what it means. And we can actually show that if we have this set up now. If I have this set up now, this is a spiral spring. This is a spiral spring. This is a pointer. I'm using an optical pin as my pointer. Now I have a set of slotted masses that I can use to show this. Now each slot is 50 gram. So I'm using these masses as the load. Now, you know, we said that extension is directly proportional to the applied force or load. So now, if I have this, if I'm hanging this here now you look at this. Look at the original length of this. Look at the original length of this now. By the time you now begin to apply force, for example, here we have about 62.2 as my original length. Now, if I apply a force now on this by hanging this has extended and it has become 64, from 62.2 to 64. Now, if I continue to increase the force, if I add another load, if I continue to increase the force, let's add another load here. If I add another load, you see it continues to extend. So as load is increasing, the extension is also doing what? Increasing. That's what that law is all about. You see it? The extension is also increasing. So increase in the load will increase the what? Extension. You see that? So as I'm increasing the load, if I add another load now to this will continue to do what? Extend. And the moment you remove this, you see, it's returning to its original size now. Yeah, it has returned to its original size. If I leave it again, you see, it extends. So if you are increasing the load, or if you are increasing the applied what? Force, definitely extension will increase. And that's why extension is directly proportional to what? To the applied force. All right. That's all for now. In our next video, our interest will be on what? On the basic expressions or basic equations that we use in calculations in Hooke's law. Make sure that you don't miss that particular word video. Bye.